Hello student of the physical science. Welcome to the 6th video in atomic structure, the periodic table. Now we don't have to go through a whole history of the periodic table, but I just thought I'd show you some variations of what people were thinking in terms of ordering all the known elements at around the 1890s or thereabouts. And there was a lot of known elements. I think chemists have been working for many years defining all these different elements, and people were starting to see trends and groupings of certain types of elements, and so they came up with all these different ideas for grouping them together. And you can see various shaped circles. Here's a three-dimensional one, and so what they were looking at is reoccurring chemical properties. And they were all competing with each other, and it was all getting a bit confusing. And then eventually Dmitri here, Mendeleev, around 1834 to 1907, that's what he looked like, pretty fiery looking dude. He came up with his own version of the periodic table, and this is a picture of what it looked like, apart from the colouring, when it was first published. And there is actually a photo of a handwritten version of this, and you can see that already quite a few elements had been discovered and named, but there were actually lots of gaps. And what's he got here? Fluorine, chlorine, bromine, iodine. You can see that that's actually group 5 on the periodic table. This one over here is his table rearranged into the modern version, and effectively it's the same, just rotated around a little bit. But you can also see that there's gaps, and these gaps he left question marks because he was predicting that elements should go there. And in fact there's lots more elements as well, but chemists could then use that as a way of trying to find these new missing elements, and they did, and there was a hunt on to find all the missing elements in the periodic table, until it got to the stage where we are now. Alright, now the periodic table in its modern form can take a number of different forms. For example, it's always going to be organised in terms of vertical columns, which are called groups or families, predominantly groups, and horizontal rows, which are called periods, and they always looks the same, although you get slightly variations of it. If you Google periodic table, you'll get exactly the same periodic table in terms of where all the elements are and the groups and the periods, but it's just got a little bit of different colour and different font, etc. And I'll show you a couple of examples of what the periodic table looks like. Here we go. That's what the periodic table looks like. It's a table. Yeah. Can also be a jumper if you're serious into knitting. Apparently knitting's getting back in fashion. You can have yourself a periodic table. You can even sleep under the periodic table if you wanted to. And you can have a shower curtain that's a periodic table. You can have a shoe that's a periodic table. You can have a periodic table with pictures. That's quite an impressive one, because it's got pictures of most of the things, or why it was named after certain people. You can eat the periodic table if you want to spend a lot of time making cupcakes. Right, back to the serious stuff though. You should have your periodic table in front of you. Have I got one? Yes, I have. There you go. Phew, that was lucky. Whoops. Yeah, there's my periodic table. So, the periodic table, whoops, that just went backwards. That's interesting. Has vertical columns, and these are called groups. So vertical columns, and we've got numbers going across them, and they are, in the modern periodic table, they are numbered 1 to 18, and you can see that on your periodic table. Might be a good idea if you got your periodic table out right now and had a look at it. Now each element in a group has the same number of outer shell electrons. Now that's important. What does that mean? We haven't really talked about outer shell electrons yet. Try and remember this. Okay, now these guys, the outer shell electrons, have their own special name called valence electrons.
Let's just repeat that again. Each element in a group has the same number of outer shell electrons, called valence electrons. That doesn't mean they have the same number of electrons. As you go down a group, they get more and more electrons, but they have the same number in the outer shell. Now, why is that important? It's important because the outer shell is the shell that defines the chemistry of the element. And so if all the elements in a group, a column or a group, have the same outer shell, they should have similar chemical properties. And we're going to look at that shortly in another video as well. Now, since it is these valence electrons that mainly determine chemical reactivity, elements in the same group usually have similar chemical properties. Not the same, but similar. There is, however, a progressive change in their properties as you go down the group. 4 groups are given family names for this reason, because they're all so similar to each other. We have the group 1, the alkali metals, the first column. Group 2, the alkali earth metals. Group 17, the halogens. And group 18, the noble or inert gases. Now here's a skeleton version of the periodic table. There's our group 1, 2, these are group 3 to 12, 13, 14, 15, 16, 17, 18, and this is showing the total number of outermost electrons. Not the total number of electrons, but the outermost electrons. And you can see group 1 has 1. Group 2 has 2. And if we jump over here, this group here, 18, is the noble gases. It has 8 electrons in the outer shell. Group 17 has 7 electrons. These are the halogens. Okay? And we'll look at that in more detail as well. Now in the next video we'll actually look at those groups and the properties that they have. Cheerio!